Notre maison dans l'espace, le système solaire, est énorme, mais ce n'est encore qu'un tout petit point dans l'univers. Les humains ont déjà marché sur la Lune, mais l'étoile la plus proche est des millions de fois plus loin. Les scientifiques ont découvert que pour y arriver, un vaisseau spatial prendrait des dizaines de milliers d'années avec la technologie d'aujourd'hui. Mais de nouvelles idées apparaissent, des moteurs qui utilisent la lumière, des vaisseaux de la taille d'un timbre-poste qui voyagent presque à la vitesse de la lumière. Cela nous fait réfléchir, est-ce que nos petits-enfants vivront sur des mondes autour d'autres étoiles? Tonight, we are not going to rush toward an answer. We are going to move slowly as light moves across the vast dark between stars, and ask a question that feels both simple and impossibly large. Will humans ever leave our solar system? Not just send a probe or a signal, but truly leave, carrying our bodies, our minds, our stories into the space beyond the sun's embrace. It is a question that sits at the edge of what we know and what we dream, and to approach it properly, we need to begin not with rockets or equations, but with stillness, with the quiet recognition of where we are right now, here on this small blue world, orbiting an ordinary star in an ordinary galaxy, looking outward into a darkness so deep that even our furthest machines have barely begun to cross it. Before we can ask whether we will leave, we must understand what leaving means. Our solar system is not a neighborhood, it is not even a country or a continent. It is a bubble of space so large that light itself, which could circle the Earth 7 fois en une seconde, prend des heures pour traverser de le Soleil à ses plus vastes étendues. We live in a system defined not by walls or borders, but by the sun's gravity and its faint whisper of light, a domain that extends far beyond the planets we name and number, out past Neptune and Pluto, beyond the scattered belt of icy bodies we call the Kuiper Belt, and into a vast shell of frozen debris known as the Oort cloud, a realm so distant that sunlight there is no brighter than starlight, where comets sleep in the cold for millions of years before some subtle nudge sends them falling inward toward the warmth we take for granted. To leave the solar system is to step beyond all of this, to cross a boundary so vast that it is measured not in kilometers or miles, but in astronomical units, the distance from Earth to the Sun, and even then the numbers grow so large they lose their meaning. One astronomical unit is about 150 million kilometers. The Oort cloud, the true edge of the Sun's gravitational domain, may extend as far as 100,000 astronomical units from the star we orbit. Think of that distance. Think of it not as a number, but as a journey. Si tu pouvais voyager à la vitesse d'un avion commercial 30 000 pieds au-dessus du sol, cela te prendrait plus de 2000 ans just to reach the inner edge of the Oort cloud, and another 100,000 years to pass through it entirely. And that is still within Notre Système Solaire. That is still home. Beyond that boundary lies interstellar space, the vast emptiness between stars, a void so profound that it makes our solar system seem crowded by comparison. The nearest star to our Sun, Proxima Centauri, is more than 4 light-years away, a distance that translates to about 40,000 million kilometers, or 260 000 unités astronomiques. Si vous pouviez y aller en voiture, en voyageant sans arrêt à la vitesse de la route, il vous faudrait plus de 40 millions d'années pour arriver. If you walked, it would take billions. Even light, the fastest thing we know, takes more than 4 ans pour faire le voyage. When we look at Proxima Centauri through a telescope, we are seeing it not as it is now, but as it was 4 years ago. The light that left it when you last celebrated a birthday is only now reaching your eyes. This is the scale of the problem, the distance that defines what it means to leave the solar system. It is not a gap we can cross on a whim. It is a gulf that demands everything we have and more. And so the question becomes not whether we want to leave, but whether we can, whether our fragile bodies, our limited technology, and our short lifespans are enough to carry us across distances that dwarf everything our species has ever known. Tonight, as you settle into rest, as your breathing slows and your thoughts begin to drift, we are going to explore this question together, not with urgency, but with patience. We will look at the barriers, the distances, the challenges that stand between us and the stars. We will consider the ideas and technologies that might one day let us cross that threshold. We will imagine what it would feel like to leave everything we know behind, to step into a darkness where no human has ever been. where even the sun becomes just another point of light in a sky full of distant fires. And we will ask not just whether it is possible, but what it would mean, not just for us, but for every generation that follows, for the long arc of human history that stretches from our earliest ancestors to the farthest future we can imagine. Where are you right now as you listen to this? Perhaps you are lying in bed, the room dark, the world outside quiet. Perhaps you can hear the faint sounds of the night, a car in the distance, the hum of a machine, the soft rustle of air moving through an open window. Perhaps you are alone, or perhaps someone is sleeping beside you, their breathing slow and steady. Wherever you are here, on Earth, in this moment, part of a species that has only just begun to reach beyond its cradle. We have walked on the moon, 250,000 miles away, an achievement that felt impossible until it was done. We have sent robots to Mars, to the outer planets, to the very edge of our solar system. We have looked deep into space with telescopes that can see galaxies billions of light years away, places so distant that the light reaching us tonight left those stars before the Earth was even formed. And yet, for all our looking, for all our dreaming, we are still here, still bound to this one world, still orbiting this one star. But that may not always be true. The history of life on Earth is a history of movement, of creatures leaving the safety of one environment and venturing into another. Life began in the oceans and eventually crawled onto land. Animals that lived on the ground learned to fly. Humans who lived in small groups learned to build cities, to cross oceans, to reach the sky. Every boundary that once seemed absolute was eventually crossed. Every horizon that seemed unreachable was eventually touched. And now we stand at the edge of the largest boundary of all, the one that separates our solar system from the rest of the universe, and we ask whether this too can be crossed, whether the same restless curiosity that carried us from the savannas of Africa to the surface of the moon can carry us further still across the dark between stars to new suns, new worlds, new possibilities we cannot yet imagine. This is not a question with a simple answer. It is not a problem that can be solved with a single invention or a single breakthrough, leaving the solar system, truly leaving it, not just touching the edge but crossing the gulf to another star, would require us to overcome challenges we have barely begun to understand. We would need to solve the problem of distance, of travelling trillions upon trillions of kilometres through a void where there is no air, no food, no shelter, nothing but radiation and silence. We would need to solve the problem of time, of making a journey that could take decades, centuries, or even millennia, longer than any human civilization has ever lasted. We would need to solve the problem of speed, of accelerating massive ships to velocities we have never achieved, and then slowing them down again at the far end. We would need to solve the problem of survival, of keeping human beings alive and healthy in an environment where every system must be closed, every resource recycled, every failure potentially catastrophic. And we would need to ask ourselves why. Why leave? Why risk everything? What are we hoping to find out there in the dark that we cannot find here, in the warm light of the sun we know? These are the questions we will explore in the hours ahead, and we will explore them gently, without pressure, without expectation. There is no test at the end of this journey, no answer you must remember, no conclusion you must reach. This is a space for wondering, for imagining, for letting your mind wander through possibilities as your body drifts towards sleep. Some of what we discuss will be grounded in science, in physics and engineering, and the hard limits of what the universe allows. Some of it will be speculative, built on ideas that exist only in theory, technologies that may never be built, futures that may never come to pass, but all of it is part of the story we tell ourselves about who we are and where we are going. A story that began when the first humans looked up at the night sky and wondered what those lights were, whether they were close or far, whether they were like our sun or something else entirely, whether we might one day reach them. And perhaps the most important thing to understand before we go any further is that this question, this dream of leaving the solar system, is not new. It is as old as storytelling itself. Every culture that has ever looked at the stars has imagined travelling to them. They have told stories of gods and heroes who crossed the sky, of boats that sailed between worlds, of bridges that connected Earth to heaven. They did not have the language of physics or the tools of modern astronomy, but they had the same impulse, the same longing to reach beyond what they knew. And now, for the first time in history, we have the knowledge to ask not just whether we want to go, but whether it is possible, whether the laws of nature permit it, whether there is a path, however difficult, that might one day carry us out of this cradle and into the wider universe. So let us begin. Let us start not with the destination, but with the journey, not with the answer, but with the question. Let us look first at where we are, at the solar system we call home, and try to understand its true scale, its boundaries, its strange and beautiful architecture. Then we will look at where we have been, at the farthest reaches we have touched, the edges we have grazed, the tiny steps we have already taken toward the larger leap that may one day come. We will move slowly, one idea at a time, building a picture not of certainty, but of possibility, not of what will happen, but of what might, given time, given will, given the restless creativity of a species that has never been content to stay where it was. As you listen, let your breathing slow, let your muscles relax. There is no hurry here, no urgency. The stars have been waiting for billions of years. They can wait a little longer. And you, wherever you are, whatever time it is, whatever thoughts are moving through your mind, you are part of this story too. You are one of the billions of people living on this small world, looking up, looking out, wondering what comes next. And that wonder, that quiet curiosity, is the seed from which all journeys grow. Before we can imagine leaving the solar system, we should acknowledge how far we have already come. There is something remarkable about the fact that we are even asking this question, that a species which spent most of its history unable to leave the surface of its own planet is now contemplating journeys measured in light years. To understand how far we have to go, it helps to first understand how far we have already travelled, to trace the path from the first tentative steps into space to the farthest edges we have touched, and to see in that journey both the incredible progress we have made and the humbling vastness that still lies ahead. It was only in the middle of the 20th century that humans first reached space at all. Before that, the sky was an absolute barrier, a realm we could observe but never touch. Then came the rockets, the slow accumulation of knowledge about propulsion and fuel, and the physics of leaving Earth's gravity well. The first satellites, small metal spheres that circled the planet, beeping their simple signals back to listening stations on the ground. The first animals sent up to test whether living things could survive the journey. And then, in 1961, the first human, Yuri Gagarin, strapped into a capsule and launched into orbit, circling the Earth once before falling back through the atmosphere, proving that it could be done, that the boundary could be crossed. From there, the pace quickened. More astronauts, longer missions, greater ambitions. Within a decade, humans had reached the moon, stepping onto another world for the first time in history. It was a journey of only a few 100,000 kilometers, a distance light crosses in a little over a second, but it felt like everything. It was the first time our species had stood on a surface that was not Earth, the first time we had looked back and seen our home from a distance, a small blue sphere hanging in the blackness, fragile and beautiful and alone. That moment changed us. It gave us a new perspective, a new understanding of how small we are and how precious this world is. But it also showed us that we could leave, that we were not forever bound to this one place, that the universe was not closed to us. After the moon, we sent machines farther, robotic probes lancées vers les planètes intérieures, vers Vénus et Mercure, mondes trop chauds et rudes pour les humains, mais fascinants dans leur étrangeté. Then toward Mars, the red planet that has captured our imagination more than any other, close enough to reach, similar enough to Earth to seem almost familiar, different enough to be endlessly intriguing. We landed rovers there, rolling across rust-coloured plains, analysing soil and rock, searching for signs of water, for hints that life might once have existed or might still exist somewhere beneath the surface. Mars devint la prochaine frontière, la prochaine horizon, le lieu où nous rêvons de bâtir des colonies, d'établir un ancrage au-delà de la Terre, un second home in case the first should ever fail us. But we did not stop at Mars. We sent spacecraft farther still, out to the gas giants, to Jupiter with its swirling storms and moons full of mystery, to Saturn with its glorious rings, to Uranus and Neptune, the ice giants at the edge of the known planets, worlds of blue and green and cold beyond imagining. These were voyages that took years, each one a triumph of engineering and patience. The spacecraft had to be built to last, to survive the radiation of space, the cold, the silence, the vast distances where no repair was possible and no second chance existed, and they succeeded. They sent back images that still take our breath away, pictures of worlds so alien and beautiful that they seem like paintings, like fantasies, and yet they are real as the ground beneath your feet, waiting out there in the dark. The farthest travelers of all are the Voyager probes, 2 spacecraft launched in 1977, nearly 50 years ago now, designed to visit les planètes extérieures et puis continuer en avant, hors du système solaire. They flew past Jupiter and Saturn, past Uranus and Neptune, their cameras capturing images we had never seen before, their instruments measuring magnetic fields and radiation, temperatures and compositions, sending all of it back across the growing gulf of space in signals that took hours to arrive. And then, when their primary missions were complete, when the last planet had been visited and the last photograph taken, they kept going. They did not stop. They continued outward, climbing away from the sun, moving faster than any object humans have ever built, carrying with them golden records inscribed with sounds and images from Earth, messages in a bottle cast into an ocean so vast that the chance of anyone finding them is almost zero, and yet we sent them anyway because it felt important, because it felt like the right thing to do. Voyager 1, the faster of the 2, crossed into interstellar space in 2012. That boundary, called the heliopause, is the place where the solar wind, the stream of particles flowing out from the sun, finally meets the interstellar medium, la fine gaz et poussière qui remplit l'espace entre les étoiles. It is not a wall, not a line you could see or touch, but a transition zone where one environment gives way to another. Crossing it was a milestone, a proof that something we made had reached beyond the domain of our star. But it is worth noting how far Voyager 1 had to travel to get there. Il a fallu 35 ans, en avançant à plus de 60 000 km par heure, plus vite que n'importe quel objet fabriqué par l'homme n'a jamais voyagé pendant si longtemps, and it reached a distance of about 120 astronomical units from the Sun. That sounds like a lot, and it is, but remember that the Oort cloud, the true edge of the solar system, extends to perhaps 100,000 astronomical units. Voyager 1 a quitté à peine le porche. It is in the yard, but the property line is still unimaginably far away, and beyond that property line, beyond the Oort cloud, lies the real distance, the gulf that separates our star from the next. Proxima Centauri, la plus proche étoile du Soleil, est à environ 270 000 unités astronomiques. At Voyager's current speed, it would take more than 70 000 ans pour atteindre l'étoile. 70 000 ans. That is longer than all of recorded human history. That is longer than agriculture has existed, longer than cities, longer than writing. It is a span of time in which entire civilizations could rise and fall, in which languages could be born and forgotten, in which the very shape of human culture could change beyond recognition. And that is just to reach the nearest star, the closest possible destination, assuming we could even aim for it, which we cannot, because Voyager is not heading in that direction, and even if it were, it is not carrying anything that could slow down when it got there. It would simply fly past, another piece of metal and memory, hurtling through the void, silent and alone. This is the gap we are trying to cross. This is the challenge, and it is not a gap we can overcome with the technology that sent Voyager into space. Chemical rockets, the kind we have been using since the beginning of the space age, are simply not fast enough. They work by burning fuel, by expelling mass out the back of the spacecraft to push it forward, and while they can achieve impressive speeds near Earth, où chaque bit d'accélération compte, ils ne peuvent pas transporter suffisamment de carburant pour atteindre les vitesses nécessaires pour les voyages interstellaires. The faster you want to go, the more fuel you need, and the more fuel you carry, the heavier your spacecraft becomes, which means you need even more fuel to move it, a spiral that quickly becomes impossible. There are limits, hard physical limits to what chemical propulsion can do, and those limits stop well short of the stars. So if we are serious about leaving the solar system, about making the journey to another star in a time frame that is less than thousands of years generations, we need something else. We need new ideas, new technologies, new ways of thinking about propulsion and energy, and what it means to travel through space. Some of those ideas already exist, at least in theory. Others are still being imagined, sketched out in equations and thought experiments, tested in simulations, debated in conferences and journals. None of them are easy. None of them are cheap. but all of them share a common thread, the recognition that the universe is vast, and that if we are to cross it, we must become something more than we are now, plus patient, plus resilient, plus willing to embrace timescales and distances that dwarf anything our ancestors could have conceived. And yet, for all the difficulty, we keep looking up, we keep asking the question, we keep imagining what it would be like to stand on a world circling another star, to see a different sun rise over an alien horizon, to know that we are no longer children of Earth alone, but children of the galaxy, citizens of a cosmos that is larger and stranger and more full of possibility than we ever dared to believe. That dream has not faded. If anything, it has grown stronger as we have learned more about the universe, as we have discovered thousands of planets around other stars, worlds that might be like Earth, that might have water and atmosphere and conditions suitable for life. Every new discovery makes the question more urgent, more real. Si ces mondes sont là-bas, s'il y a des endroits où la vie pourrait exister, ou existe, ou a existé, alors la question n'est plus seulement whether we can reach them, but whether we must, whether the future of our species depends on our willingness to leave the cradle and venture out into the larger universe. But before we get ahead of ourselves, before we start building ships in our minds and planning journeys to distant stars, we need to understand the obstacles more clearly. We need to look at the distance not just as a number, but as a problem, a puzzle with many pieces, each one requiring its own solution. We need to think about time, about the human lifespan, and what it means to undertake a journey that could last longer than any single life. We need to think about speed, about the physics of acceleration and the energy required to push a spacecraft to a fraction of the speed of light. We need to think about survival, about how to keep people alive in an environment where every mistake is fatal and every resource is finite. These are not small problems. They are not the kind of challenges we can solve with clever engineering alone. They require us to rethink what it means to be human, to ask whether we are willing to change, to adapt, to become something different in order to survive the journey. And so, as we move forward, as we continue this slow exploration of the question, we will take each of these challenges in turn. We will not rush. We will not simplify. We will look at them honestly, with clear eyes, acknowledging both the difficulty and the possibility, the limits and the potential. Because the truth is, we do not yet know whether humans will ever leave the solar system. We do not know if it is possible, if the universe allows it, if we will have the time and the resources and the will to make it happen. But we know that the question is worth asking, we know that the dream is worth holding, and we know that every journey, no matter how impossible it seems, begins with a single step, a single decision to try, to reach, to go just a little bit farther than anyone has gone before. Outside your window, if you could see it, the stars are shining, the same stars that have watched over every generation of humans since the beginning. They do not care whether we reach them, they do not know we exist, but we know they are there, and that knowledge changes everything. It makes the universe not just a place we observe, but a place we can imagine belonging to, a place where we might one day walk, not as visitors, but as inhabitants, as travelers who have crossed the longest ocean and found, at last, new shores. To understand the barrier we face, we must first understand the distance itself, not as an abstraction, but as a physical reality that defines every aspect of the challenge. We are used to thinking of distance in terms we can grasp: the walk to a neighbour's house, the drive to another city, the flight to another continent. These are distances we can cross in minutes or hours or days. But l'espace interstellaire est different. It operates on a scale so vast that our familiar units of measurement lose their meaning, where even the speed of light, the fastest thing in the universe, becomes achingly slow. Light travels at approximately 300,000 km per seconde. In 1 second, a beam of light could circle the Earth plus de 7 fois. In 1 minute, it travels 18 million kilometers. En un an, il voyage environ 9,5 milliards de kilomètres, une distance que l'on appelle une année-lumière. Et c'est cette unité, l'année-lumière, que l'on utilise to measure the distances between stars, because nothing smaller makes sense. When we say that Proxima Centauri, the nearest star to our Sun, is 4.2 light-years away, what we mean is that light leaving that star right now will not reach Earth for another 4 years and 3 months. The star you see when you look at Proxima Centauri is not the star as it exists in this moment, but the star as it was more than 4 years ago. The present moment, the now that you are experiencing, is a local thing, confined to your immediate surroundings. Out in the cosmos, time is stretched and layered, and simultaneity becomes a strange and slippery concept. But 4 années-lumière, aussi vaste qu'elle semble, est seulement le début. Proxima Centauri est notre voisin le plus proche, un élément isolé dans la distribution des étoiles. Most stars are much farther away. Alpha Centauri, le système stellaire plus lumineux dont Proxima fait partie, est légèrement plus éloigné. Barnard's star est à 6 années-lumière. Sirius, la plus brillante étoile de notre ciel nocturne, est plus de 8 années-lumière distante. As you move outward from the sun, the gaps grow. 10 années-lumière, 20, 50, cent. The stars we see with the naked eye, the familiar constellations that have guided sailors and marked seasons since humans first looked up, are almost all dozens ou centaines d'années-lumière. Betelgeuse, the red giant in Orion's shoulder, is more than 500 light-years distant. When you see its light tonight, you are seeing a star as it was during the Renaissance, before telescopes existed, before anyone knew that stars were suns like ours. That star may have already exploded, may have ended its life in a supernova, and we would not know, will not know, until the light of that explosion reaches us, centuries from now. This is the nature of interstellar distance. It is not just a matter of kilometers, but of time, of isolation, of the fundamental structure of space-time that limits how fast information can travel. Comment rapide quelque chose peut voyager. And it creates a problem that goes to the heart of whether we can ever leave the solar system. If we want to reach even the nearest stars within a human lifetime, we need to travel at a significant fraction of the speed of light. Not 10% de la vitesse de la lumière, pas 1%, mais quelque chose de plus proche de la moitié, ou plus, et cela présente des défis qui sont presque inimaginables avec notre technologie actuelle. Think about what it means to accelerate a spacecraft to such speeds. Every object with mass resists acceleration. The more massive the object, the more energy you need to change its velocity. A spacecraft carrying human beings, along with all the supplies and equipment and shielding they would need for a journey lasting years or decades, would be massive, far heavier than anything we have ever sent into space. To accelerate that mass to even a small fraction of light speed would require energy on a scale we currently struggle to generate. Chemical rockets, comme nous l'avons déjà établi, ne peuvent pas le faire. They simply do not carry enough energy in their fuel. Even the most powerful rocket we have ever built, the Saturn V that carried astronauts to the moon, could not achieve the speeds necessary for voyage interstellaire, pas du tout proche. So we need other forms of propulsion, other ways of generating thrust. Nuclear rockets, for example, which use the energy from nuclear reactions instead of chemical combustion, could in theory achieve much higher speeds. By heating a propellant with a nuclear reactor and expelling it at high velocity, a nuclear rocket could produce more thrust per unit of fuel than any chemical rocket. Such designs have been studied since the middle of the 20th century, and some, like Project Orion, even proposed using nuclear explosions, small atomic bombs detonated behind the spacecraft, to push it forward with the force of each blast. The numbers suggested that such a ship could reach a few % of the speed of light, enough to make an interstellar journey possible within a few centuries. But the project was never built, halted by concerns about nuclear fallout and the difficulty of testing such a system, and it remains a theoretical exercise, a might have been. Another idea, even more ambitious, is the fusion rocket. Fusion, the process that powers the sun, releases far more energy per unit of mass than any chemical or fission reaction. Si nous pouvions construire un fusée qui fusionne les atomes d'hydrogène en atomes d'hélium, en utilisant cette énergie pour chauffer et éjecter le propulseur, nous pourrions théoriquement atteindre velocities of 10 or even 20% of the speed of light. Such a rocket would still take decades to reach the nearest stars, but decades is manageable, within the span of a human lifetime, within the realm of what we can plan for and imagine. The challenge, of course, is that we do not yet have working fusion reactors, not ones that produce more energy than they consume, not ones small enough and reliable enough to fit on a spacecraft. Fusion power has been just a few decades away for the last 50 years, and while progress is being made, it remains an unsolved problem, a promise that may or may not be kept. And even if we solve propulsion, even if we find a way to accelerate a spacecraft to a significant fraction of light speed, we face other obstacles. At such velocities, the space between stars, which seems empty, becomes dangerous. Interstellar space is not a perfect vacuum. It contains atoms, mostly hydrogen, a few per cubic centimetre, too sparse to notice at low speeds, but devastating at high ones. When you are moving at 10 or 20% of the speed of light, even a single hydrogen atom hits with the energy of a bullet. A grain of dust, a tiny fragment of rock or ice becomes a bomb. The spacecraft would need shielding, layers of material to absorb or deflect these impacts. But shielding adds mass, and mass requires more energy to accelerate, and more energy requires more fuel. And so the problem spirals again, each solution creating new challenges. There is also the problem of navigation. At high speeds, the spacecraft cannot easily change course. It is moving too fast, carrying too much momentum. If it needs to avoid an obstacle, an asteroid, a cloud of dust, anything in its path, it must know about that obstacle far in advance, and the instruments that detect it must be able to send a signal to the crew or the computer in time to react. But at relativistic speeds, reaction time is compressed. The universe rushes toward you faster than your senses can process. You are flying almost blind, trusting that the path ahead is clear, that the maps you made before you left are accurate, that nothing has drifted into your trajectory in the years since the journey began. It is not impossible, but it is deeply unsettling, a constant low-level risk that cannot be entirely eliminated. Then there is the question of stopping. If you accelerate to a high speed, you must also decelerate when you reach your destination, unless you are content to simply fly past at thousands of kilomètres par seconde, ce qui rendrait le voyage inutile. Deceleration requires the same amount of energy as acceleration, which means you need to carry enough fuel not just to speed up, but to slow down again. Or you need to find another method, perhaps using the gravity of the destination star to brake, a maneuver that would require exquisite précision, an année de planification minutieuse, ou peut-être déployer un voilier magnétique pour attraper le vent stellaire. Une technique qui sonne élégante en théorie, mais qui n'a jamais été mise en œuvre, been tested, never been proven to work at the scales required. And beyond all of this, beyond the engineering and the physics, there is the simple, inescapable reality of the distance. Even if we could build a ship that travelled at half the speed of light, even if we solved every technical challenge, eliminated every risk, the journey to Proxima Centauri would still take more than 8 ans. 8 ans dans un espace confiné, loin de la Terre, loin du Soleil, entouré de ténèbres et de silence. 8 ans sans possibilité de ravitaillement, sans possibilité de secours, sans moyen de revenir en arrière si quelque chose se passe mal, and Proxima Centauri, remember, est la plus proche étoile. Most destinations would be farther, much farther, requiring decades or centuries of travel, even at speeds we can barely imagine achieving. This is the barrier, not a wall we can tear down, but a fundamental property of the universe, a distance so vast that it challenges everything we think we know about travel, about exploration, about what it means to go somewhere. And yet, faced with this barrier, faced with these challenges, we do not give up. We do not stop asking. We continue to imagine, to design, to dream of ships that might one day cross this gulf, of technologies that might make the impossible merely difficult, because humans have always been good at solving problems, at finding ways around obstacles, at pushing boundaries that once seemed absolute. We have crossed deserts and oceans and continents. We have learned to fly, to dive to the deepest parts of the sea, to survive in environments where no human was ever meant to live. The distance to the stars is greater than any of these, but it is not different in kind. It is still a distance. It is still a gap between here and there, and gaps can be crossed, given time, given knowledge, given the will to try. So we keep looking, we keep measuring, we keep refining our understanding of the space between stars, of what it contains, of what it demands. We send probes to the edge of the solar system. We study the interstellar medium with our telescopes. We simulate journeys in our computers, testing designs, calculant des trajectoires, cherchant le chemin qui pourrait un jour nous porter hors de ce berceau et dans l'univers plus vaste. The distance is vast, yes, but it is not infinite. It is a number, a measurement, a problem, and problèmes peuvent être résolus. As you lie there, as your thoughts begin to soften and blur, imagine for a moment what it would be like to see interstellar space, not from Earth, not from the safety of your bed, but from a spacecraft, years into its journey, long after the sun has faded to just another star, indistinguishable from all the others scattered across the black. The silence would be total. The darkness would be complete. There would be no sense of motion, no wind, no horizon, no up or down. Just the steady hum of the ship's systems, the faint vibration of machinery keeping you alive, and beyond the walls, beyond the fragile barrier of metal and ceramic and polymer, the vast cold nothing, stretching in every direction, empty and patient and indifferent. It is a distance that humbles. It is a distance that transforms. And it is the distance we must cross if we are ever to leave the solar system, if we are ever to become more than what we are now, more than inhabitants of one small world, more than children of one star. Distance is un problème, time is another, and in some ways it is the harder one, because time cannot be engineered away, cannot be solved with better fuel or stronger materials. Time is woven into the fabric of the universe, an absolute that governs everything we do, every journey we take, every life we live. And when we talk about leaving the solar system, about traveling to other stars, we are talking about time on scales that stretch human patience to its breaking point and beyond. Consider again les numéros. Even with propulsion systems we do not yet have, systems that could accelerate a spacecraft to a significant fraction of the speed of light, the journey to the nearest star would take years. Not months, not a season or two, but years, multiple years, perhaps decades, depending on the exact speed achieved. And for most stars, for most of the destinations we might imagine visiting, the journey would take much longer. Un siècle, peut-être, or plusieurs siècles. Time spans that exceed any individual human life, time spans that force us to think not in terms of passengers who will complete the journey, but in terms of generations, of families, of entire societies that will be born, live and die aboard the ship, never seeing the destination, never knowing the world their ancestors left behind. This is the concept of the generation ship, one of the oldest and most persistent ideas in the science fiction literature about interstellar travel, and it is worth exploring because it highlights so many of the challenges that time imposes. A generation ship is exactly what it sounds like, a spacecraft designed to sustain a human population not for years, but for centuries, a fully enclosed ecosystem that must provide everything its inhabitants need, food, water, air, energy, indefinitely, without resupply, without external support. It is, in essence, a miniature world, a fragment of Earth carried into the dark, and the challenges of designing such a vessel are staggering. Begin with the simplest question: combien de personnes? Too few and you risk genetic bottlenecks, inbreeding, the loss of diversity that could lead to health problems over generations. Too many and you need a larger ship, more resources, more complexity. Estimates vary, but most suggest a minimum population of several hundred, perhaps 1,000 or more, to maintain genetic health and social stability over the centuries. These people would need living space, not just sleeping quarters, but places to work, to exercise, to socialize, to raise children. They would need privacy, at least some semblance of it, and communal spaces where the society could gather, where culture could be maintained and passed down. The ship would need to be large, far larger than any structure we have ever built in space, a rotating cylinder or torus perhaps, spinning to create artificial gravity, because humans cannot live healthily in zero gravity for extended periods. Our bones weaken, our muscles atrophy, our cardiovascular systems struggle. And then there is the matter of life support. Every breath you take consumes oxygen and produces carbon dioxide. Every meal you eat produces waste. Every drop of water you use must be cleaned and recycled. On Earth, these cycles are handled by the biosphere, by plants that convert carbon dioxide back into oxygen, by bacteria that break down waste, by the water cycle that purifies and redistributes moisture across the planet. On a generation ship, all of this must be replicated artificially or through carefully designed ecosystems that can function independently for centuries. You would need farms, greenhouses, spaces where crops can grow under artificial light using hydroponics or aeroponics, methods that maximize efficacy yet minimize les déchets. You would need animals perhaps for protein or cultured meat grown in bioreactors. You would need systems to capture and recycle every bit of water, every nutrient, because there is no resupply, no chance to import what you lack. The ship is a closed system, and closed systems are fragile. Over time, things break down. Matériaux se dégradent, seals fuyant, electronics fail, accidents happen. On Earth, when something breaks, you can replace it, order a new part, find someone to fix it. On a generation ship, you have only what you brought with you and what you can manufacture from the resources on board. The ship would need extensive manufacturing capabilities. 3D imprimantes, ateliers de machines, les outils et les matières premières pour fabriquer des pièces de rechange pour chaque système critique. It would need redundancy, backups for the backups, multiple independent systems so that no single failure could doom the entire mission. and it would need a population with the knowledge and skills to maintain it all, generation after generation, passing down not just culture and history, but technical expertise, the ability to diagnose problems, to improvise solutions, to keep the systems running when the manuals are incomplete et les concepteurs originaux sont morts depuis longtemps. And then there is the question of purpose, of meaning. On Earth, people live with the understanding that they are part of something larger, part of a world, a history, a future that extends beyond their own lives. But on a generation ship for the people born in the middle of the journey who will never see Earth and will never reach the destination, what is their purpose? They are, in a very real sense, trapped, living out their lives in a metal tube hurtling through the void, neither here nor there, suspended in a liminal space that has no clear connection to anything. How do you give meaning to such a life? How do you prevent despair, resentment, the sense that you have been sacrificed for a dream you did not choose? Some have suggested that the ship could maintain a strong cultural narrative, a story that frames the journey as a sacred mission, a continuation of human destiny, something worthy of the sacrifice. Others have proposed that the society on board could be structured in ways that emphasize community, shared goals, the importance of each generation in the chain that connects the past to the future. But these are fragile constructs, dependent on social cohesion, on the willingness of people to accept their role, to pass on the mission to their children, to trust that the destination is worth the cost. History suggests that such cohesion is difficult to maintain even on Earth, où il y a de nouveaux endroits à visiter, de nouvelles opportunités, de nouvelles façons d'échapper ou de se réinventer. On a generation ship, there is nowhere else. You are born into the mission, and you will die in the mission, and your children will do the same, and there is no opt-out, no alternative. The psychological challenges are immense. Humans did not evolve for life in confined spaces, for environments without horizons, without seasons, without the natural variation that comes from living on a planet. Studies of people in isolated environments, Antarctic research stations, submarines, space stations, show that even with careful selection and support, problems arise, conflicts develop, relationships strain. People become depressed, anxious, unable to cope with the monotony and the confinement. And those are situations temporaires, durables plusieurs mois ou au plus quelques années. On a generation ship, there is no end date, no return, no moment when you step outside and feel the wind on your face and remember what it is like to be free. You are in the ship, and the ship is your world. Forever. Some have proposed technological solutions to these psychological challenges. Virtual reality, for example, could provide simulated environments, beaches, forests, cities, places where people could go to escape the confines of the ship, at least mentally. But virtual reality est pas la réalité. It is a simulation, and while it might help, it cannot fully replace the richness and unpredictability of the real world. Others have suggested genetic engineering or pharmacological interventions, ways to modify human psychology to make us better suited to life on board, to reduce aggression, enhance cooperation, increase contentment. But these ideas raise profound ethical questions. Do we have the right to alter human nature in such fundamental ways? And if we do, what does it mean for the people who result, for their autonomy, their authenticity, their humanity? And beyond the psychological, there is the social and political. How would such a society govern itself? Qui prend des décisions? Who has authority? On a journey lasting centuries, power structures will evolve, traditions will form, and there is no guarantee that those structures and traditions will be stable or just. You could start with a democracy, with a constitution, with ideals of equality and fairness, but over time those ideals could erode, could be reinterpreted, could give way to authoritarianism, tribalism, chaos. History is full of examples of societies that began with noble intentions and ended in tyranny or collapse. And on a generation ship, there is nowhere to go if the society fails. No frontier to escape to, no neighbouring culture to provide refuge or exert pressure. The ship is all there is, and if it fractures, if its social fabric tears, the consequences could be catastrophic. All of these challenges and more stem from the simple fact of time, from the reality that the journey is too long for any single human life, that we must somehow find a way to sustain not just individuals, but entire societies across time spans that dwarf our usual planning horizons. And yet, for all the difficulty, the concept concept of the generation ship remains compelling because it is one of the few ways we can imagine crossing espace interstellaire avec la technologie qui est au moins théoriquement à notre portée. We do not need faster-than-light travel, we do not need wormholes or warp drives or any of the speculative physics that may or may not be possible. We just need a big enough ship, enough resources, and enough people willing to undertake the journey, to live and die for a destination they will never see. To become the bridge between one world and another, it is a profound sacrifice, and it asks a question that each generation of humans must answer for itself. Are we willing to make that sacrifice? Are we willing to commit not just ourselves but our children and our children's children to a mission that may outlast our cultures, our languages, even our species as we currently understand it? The answer is not obvious. It requires a kind of faith, a belief that the future is worth more than the present, that the survival and expansion of humanity into the universe is a goal so important that it justifies the costs, the risks, the suffering that will inevitably come. And so we return to time, to the patient, relentless ticking of the clock that governs all journeys, all lives, all stories. Time is the dimension we cannot escape, the one that flows in only one direction, carrying us from birth to death, from past to future, with no way to stop, no way to turn back. And in the context of interstellar travel, time is the cruelest constraint, the one that reminds us that we are mortal, fragile, brief. But it is also a reminder that we are part of something larger, part of a chain of generations that stretches from the distant past into the distant future, and that our actions, our choices, our willingness to dream and to try can echo forward in ways we cannot fully imagine. The generation ship is not just a vessel, it is a statement, a declaration that the future matters, that the stars are worth reaching, that we are willing to give everything for a chance to touch them. Si le temps est la contrainte cruelle, alors la vitesse est la clé qui pourrait l'ouvrir, la variable qui pourrait transformer un voyage impossible en un voyage difficile, un voyage mesuré en siècles vers un mesuré en décennies ou années. But speed, like everything else in interstellar travel, is not simple. It is limited by physics, by the fundamental laws that govern how objects move, how energy works, and what the universe permits. To go fast, truly fast, fast enough to cross the light years in a human lifetime, we must push against these limits. And in doing so, we encounter problèmes qui sont aussi philosophiques qu'ils sont techniques. The speed of light, as we have already noted, is the ultimate speed limit. Nothing with mass can reach it, let alone exceed it. This is not a technological barrier. It is a law of nature woven into the structure of space-time itself. As an object accelerates, as it approaches the speed of light, its mass effectively increases, requiring more and more energy to accelerate it further, jusqu'à la vitesse de la lumière. L'énergie requise devient infinie. It is an asymptote, une limite que vous pouvez approcher mais jamais atteindre. And this means that no matter how advanced our technology becomes, we will never build a spacecraft that travels at light speed. The best we can hope for is some significant fraction of it, perhaps half, perhaps more, but never all the way. Even reaching a fraction of light speed, however, requires energy on a scale that is hard to comprehend. Consider a spacecraft with a mass of, say, 10,000 tons, a reasonable estimate for a vessel large enough to carry a human crew and all their supplies for an interstellar journey. To accelerate that spacecraft to 10% of the speed of light would require energy equivalent to many times the total annual energy consumption of our entire civilization. And that is just to accelerate. You would need the same amount of energy again to decelerate at the destination. The numbers are staggering, and they raise an immediate question. Where does that energy come from? Chemical propulsion, as we have established, is inadequate. The energy density of chemical fuels is too low. Nuclear fission is better, and nuclear fusion, if we can master it, is better still. But même la fusion a ses limites. The energy released by fusing hydrogen into helium is enormous by human standards, but when you calculate how much fuel you would need to accelerate a large spacecraft to relativistic speeds, you find that you would need an impractical amount, more than the ship could carry, more than could be efficiently used. The rocket equation, which governs how much fuel you need for a given change in velocity, becomes punishing at high speeds. The faster you want to go, the more fuel you need, and the more fuel you carry, the heavier the ship, which means you need even more fuel, and the spiral continues until the entire concept collapses under its own weight. One way around this is to not carry all the fuel with you, to find ways to gather energy or propellant from the environment as you travel. This is the idea behind concepts like the ramjet, un vaisseau spatial qui utilise un champ magnétique pour ramasser des atomes d'hydrogène du milieu interstellaire, funnel them into a fusion reactor, using the fusion energy to propel the ship forward. In theory, such a ship could accelerate indefinitely, limited only by the density of hydrogen in space and the efficiency of the reactor. But les défis sont immenses. The interstellar medium is incredibly sparse, only a few atoms per cubic centimetre, and collecting enough of them to sustain fusion would require a magnetic scoop centaines ou même des milliers de kilomètres à travers, une structure si grande qu'elle contraint l'imagination. And even if you could build such a scoop, the drag created by ploughing through the interstellar medium, thin as it is, would slow you down, potentially cancelling out the thrust you gain. The ramjet remains a beautiful idea, elegant in its conception, but it has never been shown to be practically feasible, and it may never be. Another approach is to leave the propulsion system behind, to accelerate the spacecraft not with engines it carries, but with external energy. This is the concept behind the laser sail, a spacecraft equipped with a large, thin, reflective sail that is pushed forward by a powerful laser beam aimed at it from the solar system. The laser, powered by solar panels or nuclear reactors, would shine on the sail, and the pressure of the light, tiny as it is, would gradually accelerate the ship. Because the energy source is external, the ship itself can be light, carrying no fuel, only payload, and this allows it to reach much higher speeds than would otherwise be possible. Calculations suggest that with a powerful enough laser and a large enough sail, a spacecraft could be accelerated to perhaps 20 or 30% of the speed of light, enough to reach Proxima Centauri in a couple of decades. The concept is tantalizing, and it has the advantage of being based on physics we understand, using technologies that, while advanced, are not fundamentally au-delà de nos moyens. The challenges, however, are significant. The laser would need to be extraordinarily powerful, far more powerful than anything we have built, and it would need to remain focused on a sail that is moving away at high speed, a feat of precision that would require sophisticated tracking and adaptive optics. The sail itself would need to be enormous, kilomètres à travers, et pourtant incroyablement mince et léger, fait de matériaux qui peuvent résister à l'intense heat and radiation of the laser without tearing or degrading. And there is the problem of stopping. A laser sail can accelerate you, but once you are far from the solar system, far from the laser, there is no way to slow down unless you carry a second sail and somehow detach the first, or unless you accept that the mission is a flyby, that you will zip past your destination at high speed, gathering ce qu'on peut de données dans les moments de passage, et continuer ensuite vers le noir. Some proposals suggest using a smaller sail at the destination, one that could be deployed to catch the light of the destination star, using that pressure to decelerate, but the geometry and timing of such a maneuver are extraordinarily complex, and it has never been tested, never been proven to work outside of computer simulations. Still, le laser sail représente l'une des approches les plus plausibles à moyen terme pour les voyages interstellaires, du moins pour les sondes petites et non humaines. The Breakthrough Starshot Initiative, announced in 2016, aims to develop exactly such a system, proposing to send tiny spacecraft, each no larger than a postage stamp, to Alpha Centauri using laser propulsion. The goal is to accelerate these gram-scale probes to 20% de la vitesse de la lumière, permettant d'atteindre le système stellaire en environ 20 ans et d'envoyer des images et des données. It is an ambitious project, and whether it succeeds or not, it represents a serious attempt to grapple with the problem of speed, to find a way to cross interstellar distances in moins d'une durée de vie humaine. But for crewed missions, for journeys where humans must survive the acceleration, the high speed, and the deceleration, the problem is harder still. The human body is fragile. It cannot withstand high acceleration for long periods. Fighter pilots experience several times Earth's gravity for brief moments, and they require special suits and training to avoid blacking out. Sustained acceleration of even a fraction of a gravity would be uncomfortable, and anything higher could cause serious injury or death. This means that any crewed interstellar spacecraft must accelerate gently, gradually building up speed over months or years, which in turn requires a propulsion system that can run continuously for long periods, something we do not currently have. And then there is the effect of travelling at relativistic speeds on time itself. This is where physics becomes strange, where the familiar rules of everyday experience break down. According to Einstein's theory of relativity, as you approach the speed of light, time slows down for you relative to someone who is stationary. This is called time dilation, and it is not a trick or an illusion. It is a real physical effect confirmed by countless experiments. For a traveler on a spacecraft moving at 90% of the speed of light, time would pass more slowly than it does on Earth. A journey that takes 10 years from the traveler's perspective might correspond to 20 or 30 years on Earth, depending on the exact speed. And at even higher speeds, the effect becomes more pronounced. At 99% of light speed, a journey that feels like a few years to the traveler could span decades or even centuries on Earth. This has profound implications. It means that even if we could build a ship fast enough to reach another star in a reasonable subjective time, the travelers would return, if they returned at all, to find that Earth had aged far more than they had, that everyone they knew was gone, that the world had changed in ways they could not predict. They would be time travelers of a sort, moving forward into a future they had no hand in shaping. For some, this might be acceptable, even desirable. For others, it would be a kind of exile, a severance from everything familiar, a journey with no real homecoming. And for the people left behind, for the families and friends and societies on Earth, the travelers would be ghosts. People who left and never truly came back, their lives and experiences separated by an unbridgeable gulf of time. This asymmetry, this strange consequence of travelling fast, adds another layer of complexity to the question of interstellar travel. It is not just a matter of distance and fuel and engineering. It is a matter of identity, of connection, of what it means to belong to a place and a time. And it forces us to ask whether the journey is worth the cost, not just in resources, but in the more intangible currency of human relationships, of continuity, of the threads that tie us to our past and our future. Speed, then, is both the solution and the problem. It is the variable that could make interstellar travel possible, but it comes with costs that are not easy to bear, costs measured not just in energy and materials, but in time, in human lives, in the very fabric of the communities we leave behind. And as we continue to explore this question, as we imagine the ships and the journeys and the people who might one day make the leap, we must hold all of this in our minds, the physics and the engineering, yes, but also the human dimension, the emotional and social weight of what it means to go fast, to compress the journey into a span of time that fits within a single life, and to do so knowing that the universe itself will bend around you, that time will stretch and warp, and that the place you left will be irrevocably changed by the time you might return. And so we continue one step at a time, building the picture, understanding the challenges, not to be discouraged, but to be clear-eyed, to see the problem for what it is, and to ask honestly whether we have the will, the resources, and the creativity to overcome it. Because if we do, if we can find a way to move fast enough, to harness the energy, to protect the crew, to navigate the hazards of interstellar space, then the stars are not forever out of reach. They are distant, yes, but distance is just another problem, and problems can be solved. Among all the ideas for how humans might cross the interstellar gulf, the generation ship stands as one of the most thoroughly explored, not because it is easy, but because it is conceivable, because it does not require physics we do not yet understand or technologies that may be impossible, because it asks us to imagine not a miracle, but an endurance, a willingness to commit not just years, but lifetimes to a single purpose. And so it is worth dwelling here, worth exploring in detail what such a ship might be, what it would require, and what life aboard it might look like, because in doing so, we confront not just the technical challenges of interstellar travel, but the human ones, the social and psychological and dimensions éthiques, qui sont tout autant redoutables que la physique. Imagine the ship, if you can. It would have to be large, far larger than anything humans have built in space, larger than the International Space Station, larger than any structure, except perhaps the largest buildings on Earth. It would need to house not just a handful of astronauts, but hundreds or even thousands of people, an entire community, multiple generations living and working and raising children in a closed environment that provides everything they need. The most common design in the literature is a rotating cylinder or torus, a long tube spinning around its axis to create artificial gravity through centrifugal force. The rotation would push people toward the outer wall, giving them a sense of up and down, allowing them to walk and move and live in a way that approximates normal Earth conditions. The size of the cylinder would need to be significant to avoid disorientation and nausea from the Coriolis effect, the strange forces that arise in rotating systems, perhaps 1 kilomètre ou plus de diamètre, plusieurs kilomètres de long, une vaste structure qui surdérangerait tout vaisseau spatial que nous ayons jamais lancé. Inside this cylinder, you would find not just living quarters, but entire ecosystems. Agriculture would be essential. You cannot carry centuries' worth of food. You must grow it continuously, using hydroponics or soil-based farming, crops that can provide a balanced diet, enough calories, vitamins, proteins, fats, all the nutrients humans need to stay healthy. Wheat, rice, potatoes, beans, leafy greens, fruits grown on vines and bushes, all of it under artificial lights tuned to the right spectrum to promote photosynthesis. These farms would need to be highly efficient, maximizing yield per square meter, using techniques that minimize water and energy consumption. Water would be recycled, of course, purified and reused in a closed loop, every drop precious, every bit of waste carefully processed and returned to the system. But farming seul n'est pas suffisant. Humans need protein, and while some of that can come from plants, from beans and lentils and soy, a balanced diet traditionally includes animal products. On a generation ship, this poses a challenge. Larger livestock like cattle are inefficient, requiring vast amounts of feed and space. Plus, petits animaux comme les poulets ou les lapins pourraient être plus pratiques, ou l'aquaculture, élevage de poissons dans des bassins, en utilisant leurs déchets pour fertiliser les cultures dans un cycle fermé de nutriments. Some have proposed insects, crickets, or mealworms, which are incredibly efficient at converting feed into protein and require minimal space. Others suggest lab-grown meat, cultured from cells in bioreactors, a technology that is still in its infancy, but which could, in theory, provide meat without the need to raise and slaughter animals. Each approach has its challenges, its trade-offs, and the society aboard the ship would need to decide what is acceptable, what is practical, what fits within their culture and their values. Beyond food, there is the air every human breathes, consuming oxygen and exhaling carbon dioxide, and this exchange must be balanced. Plants help. They take in carbon dioxide and release oxygen through photosynthesis, but the rate at which they do this must match the rate at which humans and other organisms consume it. The balance is delicate. Too little oxygen and people suffocate. Too much, and the atmosphere becomes a fire hazard, where even a small spark can lead to catastrophe. The ship would need sensors, monitoring systems, scrubbers to remove excess carbon dioxide, oxygen generators as backups, all of it redundant, all of it maintained constantly because there is no margin for error. A failure in the life support system is not an inconvenience, it is death for everyone. And then there is waste, both human and industrial. On Earth, waste is processed by natural systems, by bacteria in the soil and water, by decomposition, by the vast cycles of the biosphere. On a ship, these processes must be replicated. Organic waste, food scraps, human waste can be composted or digested by bacteria, turned back into fertilizer for the farms. Water must be cleaned, filtered, purified again and again until it is safe to drink or use for crops. Inorganic waste, broken equipment, worn-out materials must be recycled, melted down, reformed into new parts. Nothing can be thrown away, because there is no away, no place outside the system where things can go. Every atom matters. Every molecule is part of the closed loop that keeps the ship alive. The technical systems, the machinery and electronics and computers that run the ship would require constant maintenance. Things break, seals wear out, electronics degradant, mechanical parts souffrant de fatigue. On Earth, you can order a replacement part, wait for it to arrive, install it, and move on. On a generation ship, you have only what you brought, and you must be able to manufacture replacements from raw materials or salvaged components. This means the ship needs fabrication facilities, machine shops, 3D imprimantes capables de travailler avec les métaux et les plastiques et les céramiques, les outils et connaissances pour créer n'importe quoi qui pourrait être nécessaire, d'un simple boulon à une carte de circuit complexe. And it means the population must include people with the skills to do this work, engineers and technicians and craftspeople passing their knowledge down through generations, teaching their children not just in theory but in practice, hands-on, because the survival of the ship depends on it. But a generation ship is not just a machine, it is a society, and the social architecture is as important as the physical. How do people live together in such close quarters for so long? What rules govern behavior, resolve disputes, distribute resources? On Earth, if a society becomes oppressive or dysfunctional, people can leave. They can migrate to another region, start over, find a place where the rules are different. On a generation ship, there is nowhere to go. You are born into the society and you will die in it, and your children will do the same. The social structures must be stable, but also adaptable, because over centuries, cultures change, values shift, and what worked for the first generation may not work for le dixième. Some have proposed a democratic system où les décisions sont prises collectivement, où tout le monde a une voix. Others suggest a more hierarchical structure, with trained leaders or a council that guides the ship, making the hard choices that must be made to ensure survival. Still others imagine something more fluid, a society that evolves its own governance organically, adapting to the needs of each generation. But whatever the system, it must address fundamental questions. How do you allocate resources when they are limited? How do you handle crime or mental illness or conflict? How do you decide who gets to have children and how many, because population must be carefully controlled, neither growing so large that the ship cannot support it, nor shrinking so small that genetic diversity is lost? And then there is culture. The stories and traditions and beliefs that give meaning to life. On a generation ship, culture is not a luxury. It is essential. It is the framework that helps people understand their place, their purpose, their connection to something larger than themselves. The mission itself, the journey to another star, becomes a central narrative, a myth that unites the community, that gives coherence to the sacrifice each generation makes. But culture is also fragile. It can be lost, diluted, transformed beyond recognition. Languages can change, stories can be forgotten, and the original purpose of the journey, so clear to the first generation, might become abstract or irrelevant to their descendants, who have never known Earth, who have lived their entire lives in the ship, for whom the ship is not a means to an end, but simply the world. This raises profound questions. What if future generations decide they do not want to continue the mission? What if they choose to turn the ship around, or to stop, to drift, to abandon the goal? Do they have that right? The first generation made a choice, but did they have the right to make it on behalf of all the generations that would follow, who had no say, no option to refuse? These are ethical quandaries without easy answers, and they touch on the deepest issues of autonomy, consent, and responsibility. And yet, if we are serious about interstellar travel, we must grapple with them, because ignoring them does not make them go away. Life aboard the ship would be strange, beautiful in some ways, constrained in others. Children would grow up knowing only the interior of the cylinder, the curved walls, the artificial sky, the hum of machinery that never stops. They would learn about Earth from recordings and stories, see images of oceans and forests and mountains, but they would never feel rain on their face, never see a real sunrise, never stand on ground that was not metal or stone. For them, the ship would be reality, and Earth would be myth, a place their ancestors came from, distant and perhaps irrelevant to their daily lives. And yet, they would also know that their lives have meaning, that they are part of a journey, that the destination, still years or decades or centuries away, is the reason they exist, the purpose that justifies everything. Some have suggested that such a life would be unbearable, that humans would inevitably suffer psychologically, that the confinement and isolation would lead to desespoir, violence, collapse. Others argue that humans are adaptable, that we can find meaning in almost any situation, that a well-designed ship with a strong culture could sustain a healthy, happy population for as long as necessary. The truth is, we do not know. We have never tried. The longest anyone has lived in a closed environment is a few years, in space stations or research bases, and those are temporary, with the knowledge that there is an end, a return to normal life. A generation ship would be different, fundamentally different, and the only way to know if it can work is to build one, to send it out, and to wait decades or centuries to see if it arrives, if the people aboard survive, if the dream holds. And so the generation ship remains both a hope and a question, a vision of how we might cross the stars if we are willing to commit everything, to accept the constraints, to trust that future generations will carry the torch. It is not the only vision, and as we will see, there are other ideas, other approaches that avoid some of these challenges by radically rethinking what it means to travel, what it means to be human. But the generation ship is foundational, the baseline against which all other concepts are measured, because it asks us to take the journey as it is, to accept the distance and the time and the difficulty, and to find a way through not by changing the universe but by changing ourselves. The generation ship, for all its thoughtfulness, is not the only vision, and perhaps for some, it is not the most appealing. The idea of living and dying aboard a vessel, never reaching the destination, asking your descendants to carry a torch you lit, is a heavy burden, and it is natural to wonder if there might be other ways, methods that do not require such profound sacrifice, that allow the travelers themselves to reach the stars, to see the new worlds, to complete the journey they began. And so we turn now to a different set of ideas, proposals that are more speculative, more dependent on breakthroughs that may or may not come, but which offer tantalizing possibilities for shortening the subjective experience of the journey, for making it bearable, even if the objective time remains vast. One such idea is suspended animation, a state in which the human metabolism is slowed to a crawl, where the body is kept in a kind of stasis, alive but not conscious, not aging or aging very slowly, preserved until some external signal wakes it up. This is a staple of science fiction, the astronauts sleeping in their pods, dreaming or not dreaming, while the ship carries them across the years, and when they wake the journey is over or nearly so, and they have not aged, have not suffered, have not endured the psychological weight of the passage. It sounds like fantasy, but there are hints that it might be possible. Certain animals hibernate, slowing their metabolism during winter, reducing their need for food and water, surviving months in a state of deep sleep. Some species can even enter a more extreme state called cryptobiosis, where metabolism stops almost entirely, where the organism can survive freezing, desiccation, even the vacuum of space, reviving when conditions improve. Si nous pouvions induire un état similaire chez les humains, si nous pouvions trouver un moyen de ralentir en toute sécurité notre métabolisme sans causer de dégâts, alors le vaisseau générationnel devient inutile. You could simply sleep through the journey, wake up at the destination, ready to explore. But the challenge is that humans are not tardigrades, not built for such extremes. Our bodies are complex, sensitive to temperature and chemistry, and attempts to induce hibernation have so far been unsuccessful. Cooling the body slows metabolism, yes, but it also causes ice crystals to form in cells, rupturing membranes, causing irreversible damage. Cryonics, la pratique de la congélation des personnes après leur mort dans l'espoir d'un futur réveil, est basée sur l'idée que la technologie future pourrait être en mesure de le faire repair this damage. But as of now, no one has ever been successfully revived from cryogenic freezing, and the process is more an act of faith than a proven medical procedure. Some researchers are exploring torpor, a less extreme state where body temperature and metabolism are reduced but not halted, enough to slow aging and reduce the need for resources, but not so much that damage occurs. Early experiments with animals have shown promise, but human trials are years away, and even if torpor works, it is not clear how long it can be sustained, whether jours, semaines, mois, ou plus long term. Another challenge is the passage of time. Even in suspended animation, your body is not entirely stopped. Cells still function, just slowly. Radiation from space still penetrates your body, damaging DNA, increasing the risk of cancer and other illnesses. Over years or decades, this damage accumulates, and it is not clear whether the body can repair it, or whether you would wake up at the destination only to find yourself sick, weakened, unable to fulfill the mission. Shielding can help, surrounding the crew compartment with water or other materials to absorb radiation, but it adds mass, and mass, as always, is a problem, something you must accelerate and decelerate, something that requires more fuel, more energy, more complexity. Si l'anabolisme suspendu s'avère trop difficile, une autre option est d'embrasser l'artificiel, de ne pas envoyer des humains vivants, mais des embryons, congelés dans le temps, carried aboard a spacecraft, along with the machinery necessary to gestate and raise them when the journey is complete. This is the concept of the embryo ship, a vessel that carries the genetic legacy of humanity, but not its conscious minds. A ship that travels for centuries until it arrives at its destination, where automated systems wake up, begin the process of growing the embryos into babies, raising them, teaching them, preparing them for life on a new world. It is a cold idea, clinical, stripped of the warmth and continuity of lived experience, but it has a certain logic. Embryos do not need air, food, or water. They do not suffer psychologically. They do not age. They are, in a sense, pure potential, waiting to be realized. The challenges, of course, are immense. How do you raise children without parents, without human contact, without the thousands of subtle interactions that shape development, that teach language, empathy, culture? The ship would need advanced artificial intelligence, systems capable of acting as caregivers, teachers, guides, and we do not yet have AI that's sophisticated, that adaptable, that capable of understanding the needs of a growing child. Even if we did, there is the question of whether it would be enough, whether children raised by machines would be healthy, psychologically whole, capable of building a society, or whether they would be damaged, traumatized by an upbringing so alien to anything humans have evolved to expect. And then there is the ethical dimension. Is it right to create lives with the explicit purpose of colonizing another world, lives that never consented to their role, that will be born into a situation not of their choosing, on a planet they may or may not be able to survive on? These are not easy questions, and they do not have clear answers. A more radical idea, one that pushes even further into the speculative, is to abandon biological bodies altogether, to send not flesh but information, the patterns that define a human mind, uploaded into a digital substrate, transmitted across space as data, as light, as signals that travel à la vitesse de la lumière elle-même. This is the dream of mind uploading, the idea that consciousness is not tied to the specific atoms of your brain, but is a pattern, a structure, something that could, en théorie, être copié, transféré, instancié dans un autre support. If this were possible, if we could scan a brain with sufficient precision, capture every neuron, every synapse, every connection, and recreate that structure in a computer, then the person would still exist, not in their original body, but as a pattern of information, a digital mind that could think, feel, experience, all within the virtual space of a computer's memory. Such a mind would not need air or food or gravity. It would not age, would not suffer from radiation, would not be constrained by the fragility of flesh. You could copy it, back it up, run it faster or slower than real time, send it across space as a transmission, a beam of light carrying the pattern of a human consciousness to a waiting receiver at another star. The journey, which would take years or decades for a physical ship, would take only as long as light takes, a handful of years for the nearest stars, longer for more distant ones, but still far faster than any material vessel could achieve, and when the signal arrived, it could be reassembled, instantiated in a new body, perhaps a biological one grown from stored genetic material, or perhaps a synthetic one, a machine body designed for the conditions of the new world, or perhaps no body at all, the mind existing in virtual space, experiencing simulated environments, exploring digital worlds that could be anything, limitless, unconstrained by the physics of matter. It is a seductive vision, a way to sidestep almost all of the problems of interstellar travel, but it comes with profound uncertainties. The first and most obvious is that we do not know if mind uploading is possible. Consciousness remains one of the great mysteries of science, something we can observe but not fully explain. And while the brain is a physical system, gouverné par les lois de la physique et de la chimie, il n'est pas clair que la copie de sa structure soit suffisante pour recréer l'expérience subjective d'être. Si tu télécharges ton esprit, est-ce toujours toi? Or is it a copy, a simulation that behaves like you, that has your memories and your personality, but is fundamentally a different entity, while the original you remains behind, still mortal, still biological, still doomed to die? This is the problem of identity, of continuity, and it cuts to the heart of what it means to be a person. Some argue that it does not matter, that if the copy is indistinguishable from the original, if it thinks and feels and experiences in the same way, then it is you, or at least a version of you, and the question of whether it is the same you is philosophical rather than practical. Others insist that the subjective continuity of consciousness is essential, that there is a difference between you and a perfect copy of you, and that uploading is not immortality, but a kind of death, the creation of something new that carries your legacy but is not, in any meaningful sense, you. These debates are unresolved, and they may remain so because they touch on questions that science alone cannot answer, questions about the nature of self, of experience, of what it means to be. And even if mind uploading were possible, even if we could solve the technical challenges of scanning and recreating a brain with perfect fidelity, there are ethical and social dimensions to consider. Would uploaded minds have rights? Would they be considered persons, deserving of autonomy and protection? Or would they be property data that could be copied, edited, deleted at will? What would it mean to exist as a digital being without a body, without the physical sensations and limitations that define so much of human experience? Would such an existence be fulfilling, or would it be a kind of imprisonment, a narrowing of what it means to live? And what would happen to the original biological humans who did not upload, who remained on Earth or travelled in physical ships? Would there be a divergence, a split between the uploaded and the embodied, two branches of humanity that could no longer understand each other, that became, over time, fundamentally different species? These questions do not have answers, not yet, perhaps not ever, but they are worth asking because they remind us that the challenge of interstellar travel is not just about distance and speed and survival, but about identity, about what we are willing to give up, what we are willing to become in order to reach the stars. Every solution we propose, every technology we imagine comes with costs, with trade-offs, with changes to the human condition that are as profound as anything in our history. And as we explore these ideas, as we weigh them against each other, we must do so with clear eyes, recognizing that the journey to another star is not just un problème technique à résoudre, mais une transformation, un pas vers un avenir où la définition même de l'humanité pourrait être réécrite. All of these ideas, these technologies and concepts, these ships and methods and strategies are means to an end, tools to solve the problem of distance and time. But before we can decide which, if any, of them to pursue, we must ask a more fundamental question, one that is easy to overlook in the excitement of imagining starships and distant worlds. Pourquoi? Why leave the solar system at all? What are we hoping to find, to achieve, to become by undertaking such a journey? The answer to this question is not obvious, and it is not the same for everyone. Some are driven by curiosity, by the desire to explore, to see what is out there, to stand on a world no human has ever touched. Others are motivated by survival, by the fear that something could happen to Earth, an asteroid impact, a supervolcano, a pandemic, a nuclear war, something that could wipe out our species or reduce it to a shadow of what it once was, and that our only hope for long-term survival is to spread beyond this one fragile world, to establish colonies on other planets, other stars, so that no single catastrophe can erase us entirely. Still others see it as a kind of destiny, a natural next step in the arc of human history, the continuation of the same impulse that carried us out of Africa, across les océans, à chaque coin de la Terre, et maintenant au-delà, dans le système solaire et éventuellement aux étoiles. All of these motivations have merit, and all of them carry weight in the debate about whether interstellar travel is worth pursuing. Let us consider them un à un, en commençant par la curiosité avec le simple désir de savoir. Humans are, by nature, curious creatures. We ask questions, we explore. We are never satisfied with what we know. We always want to know more. This drive has taken us to the tops of mountains, to the bottoms of oceans, to the surface of the moon. It has driven us to build telescopes that can see to the edge of the observable universe, to send probes to every planet in our solar system, to search for answers to questions about the origins of life, the structure of matter, the fate of the cosmos. And it is this same drive that makes us look at the stars and wonder what is there, whether there are other worlds like Earth, whether there is life, intelligence, civilizations that have asked the same questions we are asking, that have looked up at their own skies and wondered if they are alone. Over the past few decades, our understanding of the universe has expanded in ways that make this curiosity even more compelling. We have discovered thousands of planets orbiting other stars, exoplanets of every size and type, gas giants larger than Jupiter, rocky worlds smaller than Earth, planets in the habitable zones of their stars, where temperatures might allow liquid water to exist on their surfaces. Some of these planets may be similar to Earth, with atmospheres, oceans, continents, weather, perhaps even life. We do not know. We cannot know, not from this distance. Our telescopes can tell us about their size, their orbit, sometimes the composition of their atmosphere, but they cannot tell us what it is like to stand there, to breathe the air, to see the sky, to feel the ground beneath your feet. For that, we would need to go, to send probes, or better yet, people, to these worlds, to explore them directly, to answer the questions that observation seul ne peut pas résoudre. And beyond the question of life, there is the sheer diversity of the cosmos, the incredible variety of environments and phenomena that exist out there. Planets with diamond rain, worlds covered in oceans of liquid methane, stars that pulse and flicker, black holes that warp space-time, nebulae where new stars are born, galaxies colliding in slow motion across billions of years. The universe is not a uniform place. It is a tapestry of wonders, each one unique, each one telling a story about the laws of physics, the history of matter, the possibilities of existence. To explore it, to see even a tiny fraction of it firsthand, is a goal that needs no justification beyond itself. It is enough to want to know, to want to see, to want to experience the cosmos in all its strangeness and beauty. But curiosity, while powerful, is not the only reason to leave. There is also the question of survival, the recognition that Earth, for all its abundance and beauty, is not a safe place, not in the long term. Life on Earth has been shaped by catastrophe. The fossil record is punctuated by mass extinctions, events where large percentages of species disappeared in geologically short periods, driven by asteroid impacts, volcanic eruptions, climate shifts, and other forces beyond any organism's control. Some of these extinctions wiped out the dominant life forms of their time, clearing the stage for new species to evolve and take their place. The extinction that ended the age of the dinosaurs, for example, was caused by an asteroid impact, a rock perhaps 10 kilometers across that struck the Earth with the force of billions of nuclear bombs, filling the atmosphere with dust and ash, blocking out the sun, causing a global winter that killed off most large animals and many plants. It was a catastrophe, but it was also an opportunity, because in the aftermath, mammals, which had been small and marginal during the age of dinosaurs, diversified and spread, eventually giving rise to primates, and eventually to us. But while past extinctions cleared the way for new life, they were devastating for the species that lived through them, and there is no guarantee that humanity would survive such an event. We are more adaptable than most species, more resourceful, better able to cope with change, but we are not invulnerable. An asteroid large enough could still wipe us out, or at least reduce our population to a fraction of what it is now, plunging us into a dark age from which we might never recover. A supervolcanic eruption, like the one that formed the Toba caldera 70,000 ans ago, could have similar effects, ejecting so much ash into the atmosphere that crops fail, temperatures drop, and civilization collapses. A pandemic, whether natural or engineered, could spread across the globe faster than we can respond, killing billions. A nuclear war, even a limited one, could trigger a nuclear winter, with consequences similar to an asteroid impact. And beyond these immediate threats, there are longer-term ones, the eventual death of the sun billions of years from now when it expands into a red giant and engulfs the inner planets, or the possibility of nearby supernovae, gamma-ray bursts, or other cosmic events that could sterilize the Earth without warning. Faced with these risks, some argue that the only rational response is to spread out, to establish human presence on other worlds, so that no single event can destroy us all. This is the logic of the backup, of redundancy, of not putting all your eggs in one basket. If we remain on Earth, we are vulnerable. But if we colonise la Lune, Mars, les lunes de Jupiter et Saturne, si nous construisons des habitats dans l'espace, si nous envoyons des navires vers d'autres étoiles et établissons des colonies there, then humanity becomes resilient, distributed across multiple locations, multiple systems, so that even if one world is lost, the species survives. It is a form of insurance, a hedge against extinction, and it appeals to our instinct for self-preservation, our desire to ensure that our children and our children's children have a future no matter what happens. But this logic is not without its critics. Some point out that the same ingenuity and resources required to colonize other worlds could be used to protect Earth, to deflect asteroids, to prevent pandemics, to address climate change, to build a more stable and sustainable civilization here, where we already have an atmosphere, a biosphere, a world that supports us without needing sealed habitats and life support systems. Why abandon the world that gave us life, they ask, when we could instead work to preserve it? And they are not wrong. Earth is the best planet we know, the only one with conditions perfectly suited to human life, and it deserves our care, our attention, our engagement à ce qu'il devienne un endroit où les générations futures peuvent prospérer. But les deux buts ne sont pas mutuellement exclusifs. We can work to protect Earth and also expand beyond it. We can be both guardians of our homeworld and explorers of new ones. The question is not either or, but both, and the challenge is finding the will and the resources to pursue both paths simultaneously. And then there is the question of destiny, the idea that expanding into space is not just a choice, but an imperative, a natural extension of what it means to be human. This is a more philosophical argument, less about immediate threats or scientific curiosity, and more about identity, about who we are and who we want to become. Throughout history, humans have been a restless species, always moving, always exploring, never content to stay in one place. We left Africa and spread across the globe. We crossed oceans in fragile boats, climbed mountains that seemed insurmountable, ventured into deserts and jungles and polar wastes, driven by a need to see what was beyond the horizon, to test our limits, to prove that we could survive and thrive in any environment. This restlessness is part of our nature, encoded perhaps in our genes, certainly in our culture, and it has served us well, allowing us to adapt to an extraordinary range of conditions, to become the most widespread species on the planet. Now we stand at the edge of a new frontier, not a geographic one but a cosmic one, and the question is whether we will continue that tradition, whether we will take the next step, or whether we will stop, will turn inward, will decide that the solar system is enough, that we do not need to go farther. There is no right answer to this question. It is not a matter of logic or evidence, but of values, of what we believe is important, what kind of species we want to be. If we believe that exploration, growth, the expansion of human presence and knowledge is a fundamental good, then leaving the solar system is not just an option, but a calling, something we should pursue, not because we must, but because it is what we do, because it is part of what makes us human. Si d'autre part, nous croyons que l'accent devrait être mis sur la durabilité, sur la vie dans nos moyens, sur la création d'une existence stable et harmonieuse on the world we have, then interstellar travel may seem like hubris, an overreach, a distraction from more pressing concerns. Both perspectives have their place, and the debate between them is ongoing, playing out in conferences and journals, in public discourse and private conversations. But as we lie here, as we listen to this quiet exploration of the question, it is worth considering where you stand, what you believe, what kind of future you hope for. Do you see humanity as a species destined to spread across the stars, to become citizens of the galaxy, to touch worlds that are now only points of light in the night sky? Or do you see us as children of Earth, bound to this world, responsible for its care, finding our purpose not in expansion, but in stewardship, in learning to live well within the limits of the one planet that gave us life? There is no wrong answer, and the future may hold room for both visions, for some who stay and tend the garden, and others who venture out into the unknown, each following their own path, each contributing in their own way to the long story of what it means to be human. Si nous partons, si nous trouvons un moyen de traverser le détroit interstellaire et d'arriver à une autre étoile, alors quoi? What would it mean, not just for the people who make the journey, but for humanity as a whole, for the idea of what we are and what we can become? This is where the question shifts from the practical to the profound, where we move beyond engineering and physics into the realm of meaning, of transformation, of the long view that asks not just what we will do, but what we will be centuries or millennia from now, when the journey is not a dream but a reality, when humans live not just on Earth but on worlds we have not yet named, under skies we have not yet seen. The first and most immediate consequence of leaving the solar system would be isolation. The travelers, whether they are on a generation ship or awakening from suspended animation or instantiated from uploaded minds, would be farther from Earth than any humans have ever been, separated by years or decades of travel time for signals, with no possibility of real-time communication, no way to call for help if something goes wrong. They would be alone, truly alone, in a way that is difficult to imagine. On Earth, even in the most remote places, you know that you are part of a larger world, that there are billions of other people living their lives, that you are connected, however tenuously, to a shared history and a shared culture. But on a ship between stars, or on a newly settled planet, that connection would be attenuated almost to the breaking point. The travelers would still remember Earth, would still carry its culture and its knowledge, but they would also know that they are separate, that they have crossed a boundary, that they are the beginning of something new. Over time, over generations, this separation would deepen. The cultures that develop on distant worlds would diverge from the culture on Earth, shaped by different conditions, different challenges, different histories. Language would change, evolving in isolation, perhaps splitting into dialects and eventually into entirely new languages that speakers of Earth's tongues could not understand. Values and beliefs would shift, adapting to the realities of life on a new world, where the problems and opportunities are different from those on Earth. A colony on a planet with a harsh environment might develop a culture that emphasizes resilience, cooperation, frugality, where waste is unthinkable and every resource is precious. A colony on a lush, abundant world might become more relaxed, more exploratory, more willing to take risks. Over centuries, the people on these worlds would no longer see themselves as earthlings, as humans from the home planet, but as natives of their new worlds, with their own identities, their own stories, their own sense of place and purpose. And this raises the question of unity. Would these distant colonies remain part of a single human civilization, connected by a shared origin and a shared identity, or would they fracture, becoming separate, independent cultures that have little in common beyond their biological heritage? History suggests that the latter is more likely. Every time human populations have been separated by distance or barriers, they have diverged, developing distinct cultures, languages, and ways of life. The peoples of Earth, despite sharing a common ancestry, are incredibly diverse, shaped by the geography and climate and history of the places they inhabit. The same would almost certainly be true of interstellar colonies. They would start with a common foundation, but over time, they would become something new, something unique, shaped by the worlds they inhabit and the experiences they have. And this diversity, while it might mean the end of a single unified human civilization, would also be a source of strength, of creativity, of resilience, because no single event, no single catastrophe could threaten all of humanity, scattered as it would be across multiple stars, multiple systems, chacun suivant son propre chemin. But there is another dimension to this, a deeper transformation that might occur not just culturally, but biologically. Humans evolved on Earth, shaped by its gravity, its atmosphere, its day length, its radiation environment. When we move to other worlds, worlds with different gravity, different air pressure, different levels of radiation, our bodies will respond. Some of these responses are immediate, physiological adaptations that happen within a single lifetime. Astronautes qui passent de longues périodes dans une faible gravité subissent une perte osseuse, une atrophie musculaire, des changements dans leur système cardiovasculaire. On a planet with higher gravity, the opposite might happen, muscles and bones strengthening to cope with the increased load. But over many generations, these changes could become genetic, encoded in the DNA of the population, until the people living on a high-gravity world are taller and stronger, with denser bones and more robust hearts, while those on a low-gravity world might become lighter, more delicate, adapted to an environment where weight is less of a burden. And if we embrace genetic engineering, if we deliberately modify our genome to better suit the conditions of new worlds, the divergence could be even more dramatic. We could give ourselves the ability to breathe atmospheres with different compositions, to tolerate higher levels of radiation, to see in different wavelengths of light, to survive in environments that would kill unmodified humans. We could, in essence, create new sous-espèces, ou même de nouvelles espèces, chacune optimisée pour un monde particulier, chacune portant le legs de l'humanité, but also something new, something distinct. This is a future that is both exciting and unsettling, because it challenges the very idea of what it means to be human. If we change our biology so profoundly, if we adapt to other worlds in ways that make us incompatible with Earth or with each other, are we still human? Or have we become something else, something that deserves a new name, a new identity? These questions do not have clear answers, and they may not need to. Identity is not a fixed thing. It is fluid, shaped by experience and context, and the people of the future, whether they live on Earth or on distant worlds, will define themselves in their own terms, will decide for themselves what it means to be human or post-human or whatever label fits their reality. What matters is not the label, but the continuity, the sense that we are connected to something larger, that the species that reaches the stars is in some meaningful way descended from the species that first looked up and wondered what those lights were, that asked the first questions, that took the first steps, that dared to imagine that the sky was not a barrier, but a destination. And then there is the possibility, tantalizing and terrifying in equal measure, that we might not be alone. that when we reach another star, when we explore the planets orbiting it, we might find life, not just simple life, microbes or plants, but complex life, intelligent life, civilizations that have their own histories, their own cultures, their own questions about the universe. The discovery of extraterrestrial intelligence would be one of the most profound events in human history, a revelation that would reshape our compréhension de notre place dans le cosmos, qui confirmerait que l'univers n'est pas silencieux, pas vide, mais plein de conscience, de voix, d'autres qui look up at their skies and wonder if they are alone. But it would also raise difficult questions. How would we communicate with beings whose biology, whose psychology, whose entire way of thinking might be fundamentally different from ours? How would we negotiate, coexist, éviter le conflit? Human history is full of examples of what happens when cultures with different technologies and values meet, and the outcomes are often tragic, marked by misunderstanding, exploitation, violence. Would we repeat those mistakes on a cosmic scale, or would we learn from them, find a way to approach other intelligences with humility, respect, and a genuine desire to understand? We do not know. We cannot know, not until it happens, and it may never happen. But the possibility is there, and it adds another layer to the question of why we should leave the solar system, because the search for other life, for other minds, is one of the deepest motivations we have. A search not just for knowledge, but for connection, for the reassurance that we are not alone, that the universe is a place where consciousness can arise, where questions can be asked and answered, where meaning exists beyond the frontières de notre petit monde. And whether we find other life or not, whether we settle new worlds or remain confined to this one, the act of asking the question, of striving to reach the stars, is itself meaningful. It is a statement about who we are, about what we value, about our refusal to accept limits, to be content with what we have, to stop exploring, stop dreaming, stop reaching. It is a declaration that the future is open, that possibilities exist, that we have the agency to shape what comes next, and that, perhaps more than any practical benefit, is why the question matters, why it is worth asking, worth exploring, worth devoting time and resources and imagination to. Because the stars are not just destinations, they are symbols, reminders that the universe is larger than we can fully comprehend, that there is always more to learn, more to see, more to become. And as long as we keep asking, keep reaching, keep imagining what might be possible, we remain alive in the deepest sense, not just biologically, but spirituellement, en tant que créatures qui refusent de laisser le noir définir qui nous sommes, qui insistent sur la recherche de la lumière, sur la création de la lumière, sur le transport de celle-ci avec nous, où que nous allions. And so we come to the end of this long, slow exploration, this journey through the question of whether humans will ever leave the solar system. We have looked at the distances, the challenges, the technologies, the reasons, and the consequences. We have asked not just whether it is possible, but what it would mean, what it would require of us, what we might become in the process. And now, as your breathing slows, as your thoughts begin to drift towards sleep, it is time to step back, to take the long view, to see the question not as something urgent or immediate, but as part of a larger arc, a deeper story that extends far beyond our individual lives, beyond our generation, au-delà même de notre espèce, telle qu'elle existe actuellement. The truth is, we do not know whether humans will ever leave the solar system. We do not know if we will solve the technical challenges, if we will find the energy and the resources, if we will develop the technologies that could make the journey possible. We do not know if we will have the time, if our civilization will endure long enough to undertake such missions, or if we will be derailed by catastrophe, by war, by collapse, by the countless fragilities that haunt every complex society. We do not know if we will have the will, if future generations will share our curiosity, our restlessness, our desire to reach beyond the familiar, or if they will turn inward, focus on other goals, decide that the stars are too far, the cost too high, the dream not worth pursuing. All of this is uncertain, and it is important to acknowledge that uncertainty, to sit with it, to accept that the future is not written, that it depends on choices that have not yet been made, on discoveries that have not yet happened, on people who have not yet been born. But incertitude n'est pas la même que l'impossibilité. The question is open, and that openness is itself a kind of answer, a reminder that the future is not fixed, that it is shaped by what we do, by what we choose, by the values we hold and the efforts we make. Si nous croyons que quitter le système solaire est important, si nous investissons dans la science et la technologie, si nous nourrissons la culture de l'exploration and curiosity that makes such dreams possible, then the odds shift, the possibilities expand, and what once seemed impossible becomes merely difficult. And humains ont toujours été bons dans les difficiles. We have crossed continents and oceans, climbed mountains, built cities, cured diseases, split the atom, walked on the moon. We have done things that our ancestors could not have imagined, and we did them not because they were easy, but because we believed they mattered, because we were willing to try, to fail, to try again, to push until the barriers gave way. The stars are the next barrier, the next horizon, and they will not give way easily. They demandent plus que nous avons encore donné, plus de patience, plus de ressources, plus de créativité, plus de volonté de changer, d'adapter, de devenir quelque chose que nous ne sommes pas encore. But they are not unbreachable. They are not infinite. They are just far, just difficult, just waiting, and waiting is something the universe is very good at. The stars have been there for billions of years, and they will be there for billions more, shining in the dark, patient and indifferent, neither beckoning nor forbidding, simply existing, marking the boundaries of what we know and the possibilities of what we might one day reach. And in the meantime, in the long, slow interval between now and whatever future awaits, we continue to live, to ask questions, to build, to dream. The question of whether we will leave the solar system is not separate from the question of how we live our lives, what kind of society we create, what values we pass on to our children. Si nous voulons un avenir où les étoiles sont à notre portée, nous devons bâtir les fondations maintenant. Nous devons investir dans l'éducation, dans la science, à long terme thinking that looks beyond the next quarter, the next election, the next crisis, and asks what we want the world to be 100 years from now, 1,000, 1,000,000. We must cultivate curiosity, the willingness to ask questions without knowing the answers, to explore without guarantees, to venture into the unknown not because we are certain of success, but because the act of venturing is itself valuable, is itself a statement about who we are and who we hope to become. And we must also recognize that the journey to the stars, if it happens, will not be a single event, not a moment of triumph or a line crossed, but a process, a slow unfolding that takes place over lifetimes, over generations, over centuries. It will be a journey marked not by dramatic milestones, but by incremental progress, by small steps that build on one another, by the patient accumulation of knowledge and capability. The first human to set foot on another star's planet, if such a moment ever comes, will be standing on the shoulders of countless others, engineers and scientists and dreamers who never saw the destination but who kept the dream alive, who passed it down, who added their piece to the puzzle. And that, perhaps, is the most important lesson of all, that great things are not achieved by individuals, but by communities, by cultures, by espèces, par la longue chaîne d'efforts et de sacrifices qui relie le passé au futur. This is the context in which the question must be understood. Will humans ever leave the solar system? Perhaps. Perhaps not. But the asking, the striving, the refusal to accept that the universe is closed to us is itself a kind of leaving, a stepping beyond the familiar, a reaching towards something larger. And even if we never make it, even if the journey proves too hard, the dream too distant, we will have been changed by the asking, will have become something plus que nous étions, aura étiré les limites de ce que nous avons pensé possible, et cet étirement, cette atteinte, c'est ce que signifie être humain. Au milieu, au-delà de vos murailles, au-delà de l'atmosphère, au-delà du bord du système solaire, les étoiles continuent de briller. They do not know you exist, they do not care, but you know they exist, and that knowledge, that awareness, is the seed from which all journeys grow. You are a part of this story, a small part perhaps, but a real one, and your life, your choices, your curiosities, all contribute to the larger arc, the longer tale of a species that looked up and wondered and dared to ask if the stars were reachable. And now, as you drift towards sleep, let that thought settle gently in your mind. You are here, on this small world, under this familiar sky, part of a moment in a story that is still being written. The question of whether we will leave the solar system is unresolved, and it may remain so for a long time, but it is a question worth holding, worth carrying, worth passing down, because even if the answer is no, even if we remain bound to this system, this star, this one small corner of the universe, we will have tried, will have imagined, will have reached, and that reaching is not nothing, it is everything. It is what separates us from the rocks and the dust and the silent planets that circle the sun without wonder, without question, without the spark that makes us look up and ask, what is out there? Can we reach it? Should we try? Sleep now, traveler. Rest. The stars will still be there when you wake. They have always been there, and they always will be. And whether we reach them or not, whether we leave this solar system or remain forever within it, the question will remain quiet and patient, a reminder that the universe is vast, that possibilities exist, that the future is open, and that we, for all our smallness, for all our fragility, are part of something larger, something that asks questions, that dreams, that reaches toward the light. And that is enough. That is everything. That is the thread that connects us to the stars, not through distance, but through wonder. And wonder, unlike distance, has no limit.